Hi, Ben here from moveyourmath.com. I'm going to do a video today about the Hannah's Sweets problem. This was a question that came up in a UK GCSE exam this summer and made it into the press as the impossible question that this year's exam asked. So let's have a look at it. There are N sweets in a bag, 6 of them are orange and the rest are yellow. Hannah takes a sweet at random and eats it. She takes another sweet at random and eats it. And then the question tells you that the probability that Hannah eats 2 orange sweets is a third. And then it asks you to do this. Show that n squared minus n minus 90 equals 0. And as my favourite tweet about this question put it, well, that escalated quickly. What we're going to do is we're going to look at some of the underlying theory, the underlying probability stuff that fits into this question, and then see how to apply that to tackle this question. The essential idea I'm going to be exploring is there's always an easier version of a difficult question, and you probably know how to do it. What this question does is instead of telling you how many sweets there are in the bag, how many of them are orange, and then asking you to find the probability that Hannah eats 2 orange sweets, is that it throws a curveball in. It tells you that there are n sweets, 6 of them are orange. It tells you the probability that Hannah's eating 2 orange sweets, and then it asks you to prove something about n based on what it's told you. What I want to do is just kind of fold that back for a minute to the easier version and then try and tackle that easier version to make sure we understand the underlying theory. So I'm going to get rid of that n squared minus n minus 90 bit. I'm going to suppose we haven't been told what the probability that Hannah eats 2 orange sweets is. And finally, I'm going to say, let's start right at the top and say, suppose we know there are 15 sweets in the bag. Suppose 6 of those are orange, and we do the pick 2 sweets and eat them experiment, and ask what is the probability that Hannah eats 2 orange sweets. Or in a shorthand form, there are 15 sweets, 6 of them are orange, you pick 2, what's the probability they're both orange? Now we're talking about a really basic level probability question. And if you've done any probability theory, you should be able to tackle this, okay? On the first sweet, the probability that you get an orange is just 6 out of 15. There are 6 orange sweets, 15 in total, so the probability that you get an orange one when you pick a random sweet is just 6 out of 15. So what about the second sweet? Well, for the second sweet, we've taken 1 sweet out of the bag, so we've only got 14 left, and we're supposing that the first one was orange. So what we've got is 14 sweets with 5 of them orange, so the probability that our second sweet is orange is now 5 out of 14. I'll say that again. We started with 6 orange sweets in a bag of 15. We pick the first one and suppose it's orange, so that's leaving us with 5 orange sweets in a bag of 14. And so the probability that second sweet is orange is 5 over 14. So we've got this. And then the probability that the first sweet and the second sweet are orange, you just multiply those together. So the probability they're both orange is just 6 out of 15 and 5 out of 14. And that's the basic theory underpinning this difficult question about Hannah's sweets. So let's come back to Hannah's sweets question. We're going to look at this problem, but we're going to do it with the idea that we've already understood this stuff. If we had 15 sweets total and 6 are orange, the probability that both are orange is this 6 out of 15 by 5 out of 14. And the question we're dealing with is, we've got n sweets and 6 are orange. What's the probability they're both orange? Well, this is just replacing the 15 here with an n here. So we get the first sweet is just 6 out of n. And the second sweet is just 5 out of n minus 1. If we had n sweets to start with, when we pick one out, we've got n minus 1 left. So the probability that both are orange is 6 out of n times 5 out of n minus 1. And now I can forget about the red bit. I've got the information I need about the situation that Hannah was in with n sweets in total. But now I want to remember that we weren't asked to find the probability that P was both orange. We were told that the probability both orange were a third. This was the information we're given in the question. So our first bit of answering it is just doing this thing about finding the probability that they're both orange. And then what we've got to do is set that against the fact that we're told that value, it's a third. So we've got 6 out of n times 5 out of n minus 1 must equal a third. And now what we've got to do is get down to the thing we were asked to show. We were asked to show that n squared minus n minus 90 equals 0. So our job now isn't probability, it's algebra. We've got some algebra to do on this to see if we can turn it into this. So let's have a look. The first thing we'll do is we'll actually do the multiplication of these algebraic fractions. So we get 6 5s are 30 and n times n minus 1. We do top times top, bottom times bottom. The next thing I'm going to do, I'm just going to multiply out this thing on the bottom here. So I've got 30 over n squared minus n, just multiplying out this bracket, n times n times minus 1. It's n squared minus n. So now I'm feeling quite good. Remember, the thing I was asked to show was n squared minus n minus 90 equals 0. And I've got an n squared minus n. And I've got 30 and 3 here, so maybe I'm going to get a 90 out in the end. So I'm feeling quite good now. My next step, whenever I've got something like this, I'm going to do what's called cross multiplication. So I'm going to use the fact that if this over this equals this over this, I can do a cross multiplication so that my 3 times 30 must equal 1 times n squared minus n. So 30 times 3 is 1 times n squared minus n. Well, now I just do that multiplication. I've got 90 on this side, and I've got n squared minus n on this side. And I'm very nearly finished now. To finish this off, remember my target was that n squared minus n minus 90 equals 0. I'm just going to move this 90 over to this side by making it a minus. If I subtract 90 from both sides of this equation, I take the 90, I move it over here, and I make it a minus to get this. 0 equals n squared minus n minus 90. Or in other words, n squared minus n minus 90 does equal 0 as required. So that's how you handle Hannah's sweets problem. Step 1 is some basic probability theory. Step 2 is taking the thing that you were told in the question about that probability that both are orange and using what you know about the basic probability theory to get that 6 over n times 5 over n minus 1 equals a third. And then just doing some algebra. None of this is probability theory, it's just algebra. Okay, hope that was fun and helpful. Do please come and have a look at moveyourmath.com for lots more of this sort of thing.